Welcome to our learning today. We are going to learn quite a number of things, and before we just learn much about our today's concept, I just want to remind you that mathematics is one of the key learning areas, and as much as it has its own ups and downs, it is something that you and I can do, and that is why we are here to make our learning easy. So the concept is a grade 9 concept. We are going to build a few things from grade 8 and grade 7, because it's not something new. At grade 9, we are building concepts that were learned in grade 7 and also in grade 8. So today we are going to look at compound proportions and rates of work, and I believe that you have ever interacted with such works. That is the rates of work, compound proportions. They are not something new. So if you are a grade 9 learner and also grade 8 learner, this is a lesson for you, and I believe that it's going to be wonderful to you also. So before we begin, we need to remind ourselves a few things on the rates of work and also compound proportion. So on the compound proportion, the word proportion is not something new. We learned it in grade 7. And for the word rates, it's not something new. So in this case, we are going to remind ourselves a few things we learned in grade 8. So in grade 8, we learned about rates, ratios, and proportion. Rates, ratios, and proportions. These are concepts you learned or you are guided or it is being taught at grade 7, and also a bit of it is introduced at grade 7, but a good portion is handled at grade 8. So in this case, we are going to start with rates. This is just a reminder before we go to our main concept, because it is very important as a learner you understand that before rates of work grade 9, there is a rates, ratios, and proportion in grade 8. So for you to tackle the grade 9 questions, you have to have a good understanding of the grade 8 work. So in this case, we're talking about rates. So rates gives a comparison. It gives a comparison between two quantities. Rate gives a comparison between two quantities. So in this case, we have two quantities, and then the two quantities, they are connected, that is in different ways. They are connected with a certain thing, that is what we call a rate. So in this case, we must have the quantities having different units. They must have different units, that is for the rates, and we're going to look at the ratios and proportions on how they are defined also. So in this case, for the rates, you are comparing between two quantities, and the first thing we are getting is this, that our key concept is this, that you will find our quantities, they are not of the same units. They are not of the same unit. So in this case, we can just give an example of a question. So we can have an example and then internalize that concept. So John types 60 words every 2 minutes. John types 2 words every 2 minutes. So find the rate at which he types. Find the rate at which he types. So this is just an example on how we can have a comparison. So we have two things here. Number one, we have to check out, because we have said it is a comparison between two quantities. So we have to check out the two quantities that we are talking about. So the quantity number 1, it is the quantity on watts, and the quantity number 2, it is the quantity of minutes. So our quantities are what? They are 2. The quantities are watts, and then another quantity is the minutes. So in this case, you are having the watts, and you are talking about 60 watts that can be written in what? That is 2 minutes. So the big question is this: if we are doing a comparison, then we have to ask ourselves. So we have the watts, and then we have time taken, or the minutes taken. So in this case, we have 60 watts, which can be written in 2 minutes. So our question is this: if the watts can be written in 2 minutes, that is 60 watts, what is the rate of work? So the rate of work, we are now going to look at how many watts can be written or be typed in 1 minute. So that is our question. So 60 watts, we are going to have 2 minutes. So we are expecting that in 1 minute, the number of watts that could be written, they are what? They are lesser than 60. Why? Because the 60, it is for 2 minutes. So we are expecting for 1 minute, the number is going to reduce. So in that case, if it is going to reduce, then that is the ratio of the minutes is going to give us the fraction to use. And I want to introduce something else here. Now we have what we call increasing and decreasing ratio. We are going to check on that in the next few seconds. But for our case, we are going to do a cross multiplication. But another time I'm going to introduce the ratios, and then we are going to find out how we can calculate it using the ratio. So we are going to have 60 times 1, we do the cross multiplication, and then divided by 2. We are going to get it is 30 watts per minute. So it is 30 watts per minute. So in this case, we are comparing two things. Number 1, we have the watts, and then number 2, we have minutes taken. So at this case, John types 30 watts per minute. Another question could be this: if you can type that minutes, that is 30 watts per minute, then it means that if he is given around 4 minutes, if he's given around 4 minutes, he can be able to type 4 times 30 watts. So at 4 minutes, you're going to find that he's going to type 120 watts. So that is an introduction part of our rates. So when we talk about the ratios, now the ratios, you are comparing quantities that are of the same units. Now, you can compare 2 or more quantities. So for the ratios, we are comparing 2 or more quantities. Now, the second condition, it must be of the same units. So on the same units, it means that if it has to be second, it has to be second. Kilometers and another quantity of what? Kilometers. So in this case, number 1, understand that for our ratios, we are comparing 2 or more quantities. And the condition number 2, they must be of the same units. So in this case, our ratios can be written in 3 ways. So our ratios can be written in 3 ways. Our ratios can be written in 3 ways. Roman 1 as a fraction. Roman 2, you can also write it with colon, that is a separation. You can write it with the colon. So, for example, in this case, it can be written as a fraction. That is b out of c. It is b out of c. And then with colon, it is the same as b is to c. And then you can also write it in statement form or using word. Using word, you can say B to C. So we have three ways you can write our ratios. Number one, you can write it as a fraction B over C. The same ratio, it can be written in what? With the separation that is of the full colon in between. So B to C, and then using word B to C. So those are the three ways we are going to, that is write our ratio. So another thing we need to note, our ratios, the ratios have to be written, the ratios have to be written in their simplest form. Their simplest form. So in their simplest form, it means that the numbers which are giving us the ratio, they can no longer be divided, or they cannot divide each other. For example, I want to write a ratio here, and in terms of fraction, so a ratio like 4 out of 6, or 4 over 6. In this case, we have a number that is common between 4 and 6 that can divide both 4 and 6. So this one can be written as 2 out of 3, or 2 over 3. So 2 over 3 means that 2 goes or divides 4 by 2, 2 divides 4 by 3. So 2 and 3 cannot be divided any further, and it can be written as a ratio in terms of 2 is to 3. It can be written as a ratio of 2 is to 3. So in this case, there is an importance of us writing in fractions and also in what? A ratio form. So because you will find that in one of the simplest questions you can find in an exam is write, let me give an example, write the following ratios as fractions. So write the following ratios as fraction. Part 1 and part B, we have 3 is to 7, and then 4 is to 9. So for this first case, the first number becomes our, that is numerator. So for our case here, we are going to have the first number becoming the numerator, that is 3, and then we have the division line, and then the second number becomes the denominator. The first number becomes our numerator, and then we have the second number being our denominator. So the same can be done, that is when writing numbers from fractions to ratios. This concept is very, very important, so that when we are going to now work out questions on rates of work or a combined effort, that is a combined work on the rates, ratios, and proportions, we are going to have division of quantities in certain ratios. It is going to be very, very important. And then I want to just give two types of ratios in which we can incur. Number one, in the division of, that is a quantity, or increasing or decreasing a certain quantity, you have to understand something called an increasing ratio. Increasing ratio. And then number 2, we have a decreasing ratio. So when talking about increasing ratio, this is an application concept on the quantities. So the increasing ratio, it means that when you take the ratio, convert it to a fraction, and multiply it by a certain quantity. So the quantity is going to increase in terms of its value. It is going to increase in terms of the value. Now, when you take a decreasing ratio and then convert it to a fraction, so that fraction, when you multiply it by a certain quantity, then it means that our quantity is going to also decrease. Now, in regard or in connection with this, I want to remind you about some two very important things. That is types of fractions. So the types of fractions, we have three types. Number one is types of fractions, proper fraction, and in this case, the numerator is smaller than the denominator. That is something like 3 out of 5. And then number two, we have improper fraction. So the improper fraction, it means that our number that is on the numerator is bigger than the denominator. Our number on the numerator is bigger than the denominator. So it is going to be an example like 7 out of 5. And then, so the improper fraction, because you cannot write our answers unless asked to write it so, our improper fraction can now be redefined to a mixed number. So we have a mixed fraction. So for the mixed fraction, we have a whole number, and then we have the other set of the number being a fraction. So a mixed number is combined of two sets of numbers, a whole number and a fraction. So we can have an example of 2, 1 out of, that is 2. 2, 1 out of 2. It means that there is 2 as a whole number, and then half is what? A fraction. Now, why have I introduced this? It is connected that is the concept of decreasing and increasing ratio. So how do you identify an increasing ratio? So for an increasing ratio, when converted to a fraction, it results to an improper fraction. Then number two, for a decreasing ratio, when converted to a fraction, it results to a proper fraction. Now, this is the reason as why I introduced these 2 or 3 types of fractions. So in this case, these 2 statements are very powerful when we are going to get to do what? Our increasing ratios and decreasing ratios. So the first statement, in increasing ratio, when it is converted to a fraction, it results to an improper fraction. And then number 2, for a decreasing ratio, when converted to a fraction, it results to a proper fraction. So it simply means that we're talking about increasing ratios, the first number on the ratio is bigger than the second number. And a good example, we can have 3:2, we can have 4:3, we can have 9:7, you can have 100:99. So that means that the first number is going to be, that is bigger than the second number. And then number 2, for our decreasing ratio, the first number is smaller than that is the second number. So in that case, we can have 1:3, then we can have 4 is to 5, 900 is to 1,000. But remember, our fractions, our ratio, they should be in that simplified form. But in an exam situation, can be given such like, and then you're supposed to do what? Make it more singular. So by this, we are now understanding the concept of increasing ratio and decreasing ratio. This concept is very, very important in the questions we are going to be doing in a few minutes from now. So after that, we have another concept. We have the third concept, that is proportions. So when talking about proportions, what does it mean? You can take your 2 seconds to remind yourself on proportions. What do they mean? Remind yourself on proportion. Remind yourself on proportion. So in this case, a proportion is an equation stating that two ratios or rates are equal. So if two ratios or two rates, they are equal, then it means that there is something we have to do what? We have to connect. So in proportions, we are talking about rates and ratios being what? Being equal. That is the concept for grade 8. For them being equal, it means that our proportion can be written as, if we have a ratio or a rate that is in fraction form, it is written as A out of B is equal to another ratio or another rate, B, that is C is to D. So A is to B, A or B, C is to D. So this one can be written in terms of ratios. A is to B is going to be equal to C is to D. So in this case, we are equating two ratios or two rates. How far something can be done, that is what we term as the rate. So in this case, we can have a cross multiplication of our ratio. So for example here, you can be given a question and then you're supposed to find a solution for it. So you'll find that in the questions of proportions, one of the letters is going to be missing, or one of the variables that are given are going to be missing. So for this case, this one can be simplified as, if we do cross multiplication here, A times D is the same as B times C. A times D is the same as equal to B times C. So I give a question so that we understand what it means. So the ratios, A is to B is to C is to D are said to be in proportion. Are said to be what? In proportion. If A is equals to 4, B is equals to, A is equals to 4. So really let me use a different question here. A is equals to 4, B is equals to 5, B is equals to 5, sorry. And C is equals to 80. Find B. So the ratios A is to B is to C is to D are said to be in proportion. If A is equals to 4, B is equals to 5, and C is equals to 80. So you are supposed to find our ratio, that is the value for B. So in proportion, if there are 4, we have A out of B is equals to C out of D. So you have been given A, B, C, so you replace the variables that are given, or the letters with the numbers, that is the respective numbers. So we have A is 4 out of 5 is equal to C, it is 80 out of D. So from this concept, we have AB, that is AB is equal to B, C. That is cross multiplication for the letter. So it means here 4D is equal to 80 times 5. So 80 times 5, that is 400. 4D is equal to 400. So divided by 4, divided by 4. So our D is equal to 100. That is the value of D. That is the value of D. So in that case, it means that the rates, ratios, and proportions concept in grade 8, it is a very, very important concept. And that means that for you to be able to solve the grade 9 concept, you have to have a mastery of that concept. You have to have the mastery of that our concept. So for today, we are going to, there is end the part 1 of our learning, and then our part 2 of the video we shall check on the grade 9 work now, compound proportions and rates of work. Ensure you check out for the next, that is a video that is coming on the lesson on compound proportions and rates of work. It is just next on our channel.